Good afternoon. If big data at the intersection of containerization and infrastructure as code is not your final destination, now would be the right time to deplane. But since you're still here, let me tell you a little bit about myself. About me. Yes, that is me. Guess I was a little bit younger then. But in more particular, I've been programming since high school back in 1968. Stop laughing. Someday I'm going to get this right. The stuff I used to work on back then was kind of interesting in my mind. This was my very first computer. It's called an IBM 1130. It had all of 8 kilobytes of core memory. It actually had a disk drive that was 5 megabytes big. But the big thing about it is that it used cards. Now, this happens to be a really special card because this is what was called an IPL card. So you could put this into the card reader, punch the initial program load button. It would swoop in this card, and then start executing the instructions. These 12 bits were extended to the 16-bit word length of the machine. This particular program copies all the cards in the input stack to the output stack. That's it. But I loved that kind of stuff. The IBM 1130 has real memories for me. I started working with computers full-time since 1975. I was a junior in college. I kind of needed the money. I had the pleasure of working at all levels in industry, both as an individual contributor and as an executive, in both commercial and in scientific work. I think of myself mostly as the person that I was when I was a commercial software architect. My first product had to do with computer-aided engineering. I love that stuff. But time marches on. 2003, Agile was young, and I started consulting. And one of the things that helped me was I knew a lot of the people in the coaching space. And to be successful back then, you had to be both a process and an extreme programming coach. Now, I still have that passion about computers, but nowadays, there's so many companies out there that want to sell you stuff. Oh, they're going to make you agile. They're going to make you better. Just buy it. We've sort of become the stuff that we fought against in the agile revolution, right? Some of the biggest differences now are that we have different words for things like our old silos and requirements and process stuff. It all got out of really hand for me about 4 years ago at Agile Indy 2017, where I just kind of stopped in the middle and said, I'm not doing this anymore. I quit. I am not part of the Agile movement. It's gotten too industrialized and too commercialized. And it's been fine since then. But if you were to ask me, who's my hero? Without hesitation, I would say Richard Feynman. That's him. Now, Richard Feynman was the guy that helped build the atomic bomb for the United States during World War II. He became a public figure in the mid-'80s because he served on the Rogers Commission, which was founded for the Space Shuttle Challenger explosion. And he's the guy that came up with the theory that it was cold O-rings that, made it explode. By the way, he won a Nobel Prize in physics in 1965 on his contributions to quantum electrodynamics. Now, in 1974, Feynman gave the commencement address at Caltech. That's him in his regalia. And he spoke about a cargo cult science, a form of pseudoscience in which an imaginary hypothesis is offered after the fact for some observed phenomenon, and further occurrences of that phenomenon are deemed to be proof of the hypothesis. Now, today we practice cargo culting in many ways, but one that we do is when we blindly copy the stuff that organizations that are like us do to get results. And we want to know about that, and we do the same. When he died, Feynman left something on the upper left-hand corner of his blackboard. And this is the picture from Caltech. Know how to solve every problem that has been solved. That's kind of weird. Now, my take on it is that memorizing physics formulas is just hopeless in the long run. Okay, but by knowing a few key things and understanding the principles, you can work out whatever details you need. And so it is with very complicated software frameworks. I'll never understand the thing that we desire without building it from just a few key principles. And once we build it, we know how to solve all the problems in that domain by doing them if they're not obvious to us. And that's why we start here, where we are today. So this is how we're going to proceed. We're going to first recognize what our goal is. Right? We've got to keep that goal in mind. We've got to print it in big letters and put it on the wall right behind us or in front of us so that we can see it when we want to look. Tattoo it on your body backwards, if that helps. Call it a memento. And for this project, what we're looking to do is to help people self-provision their own Apache Hive environments for both their desktop and in the clouds so that they can use very large data sets and perform SQL-like operations for data that resides in Apache Hadoop clusters. Okay, now for entertainment, I want to give you a quick demo of what we're trying to avoid, that are systems created from cargo cult creations. And this is a demo of one organization's CI/CD pipeline prototype.
Rube Goldberg machine attempt 3. Fuck. Right.
Never fails to amuse me. Here's the CI/CD server running. Oops. Didn't run in AWS. Well, we can help it along a little bit.
Oh, yeah. You just look at yourself. Fuck.
SSHing. As your Scrum Master might say, go team! So, the important thing is that we start with why. Now, the repository that goes along with this presentation started off as a real-world project that I faced recently. Our group knew that it needed to start supporting Apache Hive on Hadoop clusters. Unhappily, they knew nothing about Hadoop, Apache Hive, AWS. So one possibility was for them to start doing something that another organization was already doing, and that was using the AWS console and creating AWS EMR instances. Those are the managed platform stuff that Amazon gives you for supporting Hive, MapReduce, Hadoop, all that stuff. Honestly, what could go wrong? Right? Well, how about everything? Because even if the instructions were followed to a T, there would be a disaster. Now, that's why I was very much against the idea, because we wouldn't be learning anything. We'd be reduced to mere users of a vendor-centric solution that would increase our cost of switching should we decide to choose the way that we were doing it, like moving to a different cloud provider. Instead, I showed the group how to learn to run on Docker desktop and orchestrate instances using Docker Compose, gave them some Terraform scripts to create clusters in an AWS cloud, and all that stuff could be customized for their needs using things like AIC, or infrastructure as code, the concepts that Terraform does, right? I was not giving them the solution to their problem. I was giving them the means to learn about how to solve the problems. Remember, we don't have to become experts at the underlying principles and practices, at least not experts in every possible thing. What we do need is some background to gain perspective and to help us through the swirling solution waters that lie underneath. Because once we know why, we can start to proceed to know how. So in our case here, we need to start with some data to work from. Now, our users are telling us, oh, we've got these petabytes, these exabytes of data that are out there. But don't do that. Start with a known data set in maybe a gigabyte range or something. Big enough to be useful, small enough that allows us to do it many, many, many times in small experiments. Then we're going to have to learn about data cleansing so that we can import the data into our data set easily, right? And we can query against it and import it without any problems. It's also nice to start with containerization so that we can quickly install those components to our local machines and test out what we're going to be doing. There we can gain enough experience to issue commands for things like importing and querying the data, as well as monitoring the components like Hadoop and the Hive. Now, I chose Docker for this because we won't have to install anything on our systems. We can use those Docker containers to create environments on demand. And installation and modification doesn't affect our host environments. Once we're comfortable that we understand the components and how they all work together, then we can start to use infrastructure as code to create the scripts that permit us to create, provision, and test the environments in our ultimate cloud environments. So let's take a look at some of that code, right? Not going to show you everything here, just the highlights. We don't have enough time. First, how about getting the data and starting to clean it up? Now you'll see this is already recorded, so I can get the time right.
All right, well, let's start taking a look at the code and understanding. As you can see, I'm inside my editor right now, looking at the README, we're going to be talking about data that comes from the United States Medicare service, and the URLs are there inside the README. You can take a look at them yourself. Once we get the data down, we're going to have to start to contend with some issues. And it's primarily because of what you're seeing here, right? The data itself that comes to us, is a typical CSV format. The data uses, one of these notations that has embedded quotes around all the fields that are important. And, that's to preserve things like commas inside of it and quotes inside of it and other stuff like that. And most databases can handle this sort of a quoted CSV file. Not Hive. Hive is pretty particular about stuff. All right. So, for example, if we were to look at commas inside the quoted fields, these kinds of things, they're not going to work. All right, it's going to see the comma and say, "Ooh, look at that, a new field." Same kind of thing goes with the quotes. All right, just because this quote is inside of quotes, Hive doesn't care. All right, that's just part of the field. And even more to the case, Hive has no facilities for transforming. So normally you would take a date like this, which is a typical U.S. sort of a date. Hive wants to store it with 4 digits of year, 2 digits of month, 2 digits of day. Well, that's not going to happen either. So that's the reason that this Python script exists. It does all of the things necessary to take your file in and do all the massaging on the data to clean it up. When it's run, all right, it'll take a period of time. We took almost 10 minutes just to transform it, and it took 3 minutes just to download it. Anyhow, it's all inside of the thing. You can take a look at it at our leisure. We don't have time right now. And when you look at the output from it, you can see that it's nice, simple CSV format. And that's exactly what we want for this project.
All right, so now let's start learning about Apache Hive by running them inside of Docker containers.
All right, let's talk about why, in fact, the project's going to be done when we have AWS instances running. All right, that's the most important section of this piece. All right, it is that Docker containers, and you can read, my various notes in here. give us a way of quickly experimenting and getting feedback immediately, rather than waiting for a long time to bring up a server, or a set of servers, a whole environment, in cloud or on other machines inside of our network, right? And it also gives us a chance to explore the environment so that when we do get to the point where we're bringing up machines, we know what we're doing and not wasting more time at that point. It's all a matter of learning, incrementally learning, iteratively understanding more and more and more, right? So for teams that are not used to what Apache Hive has to offer, and their only knowledge of Hive is that, how to spell it, this is a nice little diagram to talk to that, talking about what parts are Hadoop and, for storage, and what parts do the MapReduce stuff that goes on. We can also talk about that, but this is neither the time nor the place. And then talk about the three pieces that are Hive specific, namely the Hive server, the part that a user will interact in SQL fashion, the metastore, talking about how the data is formatted into that way that defined by the schema that the user can understand it with, and the role of the persistent Rdbms that goes with it. All right. For me, it's really nice to start a team going by giving them a Docker YAML, Docker Compose YAML, that gives them a starting place, right? Gives them a place to understand where they can find images, or that you as a coach may have to build, or in this case, I was able to get them from Big Data Europe 2020, all right? Give them an idea of what kind of ports are being used for communication, give them an idea of which portions of this have persistence, all right? So persistence stuff will show up inside here. Give them ideas of what the dependencies are between the various components. So for example, our metastore is going to make sure that there's a Hadoop instance running on these particular two nodes, communicating through that particular port, and that there's a PostgreSQL running on that port. Right? It can also give them a starting point for the types of configuration necessary just to get them started. Again, repeatability is the important key. Right? If you can give them something inside of a repository that allows them to work with it, rather than just some doomed Zoom call, everybody kind of looks this is important. So for those of you that are not familiar with Apache Hadoop, but are in a similar situation, this is a great place to go on and do your learning. Right. So let's just talk about these four particular scripts that all start with a number 02 through 05, containerized. There's a Hive startup, a smoke test, a Hive test, and then shutdown. Right. So it all starts with the O2 containerized Hive startup test script. Right. Heavy lifting being done by Docker Compose. I just have to tell Docker Compose where my YAML is, tell it to bring up everything as daemons. All right. I then just have to wait, looking at the logs inside of Hive server, for this particular phrase to start showing up, starting Hive server. All right. I could have picked others, but again, you can, this is for people learning about it to go and observe what's going on inside of this. And when it does start, right, when I can start seeing those results inside the log, tell them that it's started up. When you run it, nice and simple. They don't have to understand all the vagrancies of AWS and Terraform or whatever to get started. They simply see that there's a network, 3 volumes created, and the 5 containers. It's waiting for Hive to get started, meaning that the subcomponents have all started and are communicating with one another. And it says it started. But how do we really know that it started? Right? You could tell people to take a look at Docker PS, which tells them that there are 5 containers and they're all running. That's great. They haven't crashed yet, but how do we know that they've actually started correctly? We could have them go back and look at the log files, which quickly start to overwhelm, right? Because it looks good, I don't see anything particularly wrong, but we need a lot to go and scan those to figure it out. So the best thing to do is to start off with small tests, right? And in terms of small, the test that I grew up with, that many of you did, came out from Kurgan and Ritchie when C came out, and it printed out Hello World. It's a nice small smoke test that C is actually running, right? Doesn't do everything, but it tells us that some pieces are working. Similarly, we want something to tell us that Hadoop and MapReduce are working. Luckily, Apache, for its Hive project, gives us that smoke test, right? It gives us something that kind of looks like this, all right? And it's called word count. And what it does is it accepts a bunch of files, right? In this case, I'm going to stuff it with files that say time flies like an arrow, fruit flies like a banana, and rose to put rose on her rows of roses. And what word count does is it scans, parses each of the files that come in, and counts the words that are replicated. So I can put together what a successful test would look like, right? And these are all the words, and next to them are the number of instances. Then I can build up a small script that actually does this test from first principles, right? It's able to actually run the compiler, jar up all the results, print out all the inputs, use DFS from Hadoop to make directories and put files into it, use Hadoop to run my word count program, taking all the output and putting it over here. I can then go and print out the output that comes from it, copy it locally into something called mr.text, run diff against mr.text and my answer key, and either print out in big green letters that it was a success or in big red letters that it's a failure. And then finally, I can put together this O3 containerized Hadoop smoke test, which simply copies all of the pieces that I need to run the test onto the node that is already up and running and executes my test script. And when you run it, it comes up and does what we expect, says it was successful. It's also important that when you test, that you not just test for success, but test that it fails and fails for the right reasons. So I went and changed the key that gives it the answers, and I changed the count from files from from 1 to 2. And when I run it again, it fails, and it fails for the right reasons. Well, that's great. All right. But now I have to learn a little bit more about Hive, so that when we actually do the integration at the higher level, that I can make sure that the data and SQL is actually running, and learn how to format that stuff and put it all together and make it work. Right. The first thing is going to be to put together a schema file for it, which I've conveniently done for you over here with the PGYR 2019 .schema. Kind of looks like that. You're going to need to learn more about the serial and deserialization properties, which is how it works with CSV. Right? And when that's done, I can start to put together my containerized Hive test, the O4 script. And all that that's going to be doing is copying in the schema into the Hive server component container, using Beeline, which is the client that we use to communicate with the server, and then putting together the schema into something that gives us tables, displaying those tables. Again, I'm going to use some of the Beeline commands and learning about how to make that happen. Bringing in some sample data, right? So to do that, I'm going to take the first 1% of the data that I've converted, stick it into Hive server, execute the command, right, that will allow us to actually run it. So I have to learn that there's a beeline command for load data in path and actually run that command. I might want to output from DFS where the data is being kept. All right, so I'm going to use this, another DFS command. I'm going to use beeline to print out the first two rows of the data. All right, so people with SQL knowledge will get an idea of what that looks like. Right? They should all be able to do that. Count the number of the data. Again, just like SQL. They'll see this and they'll know what to do. But now they'll know how to do it using beeline. Run a simple aggregate function. Here I'm going to be running AVG and learning how to format it. Running a much more complex aggregate function so that I could print out the total amount of payment to physicians and then order it decreasing by the amount of payments and then group them by the physician's name and take the first 10 of those. Again, see how to make that work. When we run that test, we'll get to see that the schema gets created over here, that the table was created for us when the schema was in there. We'll get to see that here's our data, which is only 4.8 megabytes of data, because we only are taking a small sample here. We're going to get to see that what the first two rows and the first 240 columns look like, count the average of the total of the payments, and then which doctors are getting the most money. So at this point, all that we have to learn is how to shut it down. Again, Docker Compose does all the heavy lifting. Say Docker Compose, here's that YAML file, bring everything down. And oh, by the way, while you're at it, delete those 3 volumes because we're not interested in persistence at this point. And when I run it, it does exactly what we expect. Removes all the volumes just like we expect. We do a Docker PS and there's no containers. We do a Docker volume ls and there's no volumes. Okay, take a breath.
All right, and finally, let's go into some details on taking what we've learned so far about Apache Hive and applying it to building AWS environments on demand.
Okay, now that we've learned a bit about how Hadoop and Hive works, what it takes to set up a repeatable environment, and how to run automated tests against that environment to ensure that it's working, let's tackle the rest of this project. Our time here is quite limited today. I'm going to give you some highlights, but you're going to have to look at the repository's README for the rest of the gory details. Okay, I looked over my shoulder and I read those words on the wall that I wrote. And they still say, help people self-provision their own Apache Hive environments. So what are we missing to do that? And I'd say 2 primary things. One, we need to fully realize the Apache Hive promise. Use clusters, more powerful machines, and the web UI tools provided by Apache Hive. And number 2, we also need to start treating all the infrastructure that we're about to create as code so that we can spend our time describing the environment and make it repeatable and automatable across different cloud providers, rather than manually doing each piece inside something like the AWS console web UI. Now, we're going to put together an environment that will have 1 Hadoop name node, 4 Hadoop data nodes, 1 Hive Rdbms, 1 Hive Metastore, and 1 Hive server using AWS EC2 instances. And we're going to do this to be fully configured and tested by code. So this phase of the project is going to be run with 4 files that mimic the 4 files we interacted with in the Docker portion of the project and extend them to be useful in an AWS environment through infrastructure as code tool known as Terraform. Let's take a look at those 4 files to get a sense of what's going on. Now, the first one, the 06 AWS Hive startup script, is in the entirety of what you need to bring up all AWS instances, all 8 of them, and provision them into a cluster ready to test from. There's a simple AWS S3 make bucket that is going to be used to allow us to keep portions of that cluster together so that one instance can look at another. And all we're going to have to do once we do that is do a Terraform init and apply. Okay. The second script, the smoke test script, the reality of it is that the stuff that goes on down here, all of these things that are invoking my local remote copy and remote execute scripts, are very analogous to what we did with Docker. We copy and run remotely here on our name node. Then looking at the Hive test script, again, very similar to what we did in Docker. We're simply copying and running on the Hive server here. And the 09 script, the shutdown, is just the inverse of the 06 script. We tell Terraform to destroy everything that we put together, and then we remove that S3 bucket that we put. And you should look at the code. That's kind of a clever way for one instance to find out some details about another for cluster formation. So let's take a look at this script that's used by Terraform, this one that's doing the HDFS data node. And it's one of the more interesting ones. I'm not going to go through it in entirety. I just want to show you, that the big pieces are pick an AMI to work from, very similar to the from command in Dockerfile. Find an instance type, that corresponds to your wallet and ego. Bigger is always better. Make sure that we can pass along the SSH keys. Make sure that we can bring in the security group, which is going to have all of the ports and the security, the web security that we need. Talk about how big and how fast the disk is that's going to run on here. This count, this is the only of these scripts that has a count, because we're going to cluster 4 of these together, and they're all similar. Right? There's a tags portion in here, which is also used by the script that do the provisioning. The status is either going to say provisioning, provisioned, or running, and that's how they're going to know to coordinate with one another, so that one instance won't start running until the dependent upon instances are already running. And the rest of these things are provisioner statements. This one you'll see in every one of my scripts, and it's my clever way of using AWS command line to not start pumping commands to provision the AWS instance until we're all ready to do that. Now let's take a simpler one as a better example of the rest of this. And that would be this one for provisioning the Rdbms. You know what that stuff is? The provisioners, you'll see all look very similar. For provisioning a file, that means to copy this file to that destination. If you see a remote exec, it's going to say, all the same kind of things. There's going to be a provision step that takes us into the provisioned status of one script that finishes the configuration, starts the instance, and checks to see that it's running, and then puts it into the run status. The provision scripts always look sort of like this. It's not that intimidating. All right. Really, the active portion is this apt-get install. So we're putting together all of the RPM packages that we need to make our instance run. We get some information about the metadata that we're talking about, so we can find out our DNS name, IP name, blah, blah, blah. And we save that information in a bash profile. This is the simplest of the run scripts. Remember, he's not depending on anybody, so it's going to look a lot simpler. But when he does his running, he's going to do some, little configuration stuff in here. He's going to do a statement to get the server up and running. He's going to be checking to make sure that it actually does start to run. In this case, he also puts together the very first database on that server. And this is him setting the status of that instance to running. Let me just give you a brief idea of what it looks like on the actual console. All right, you're going to see a lot of the stuff when you first start initializing and then applying, talking about which pieces. You'll always get to see the name of the instance that we're talking about. So this is the third instance of the Hive HDFS data node. This is when those local scripts are running to say, well, let's wait until AWS is ready for us, and then we'll start pumping away stuff. When they finally do start pumping away stuff, you'll see that he's doing his provisioning of reward execs, sending up files. The actual scripts are going to be putting stuff, color-coded, in my case, onto the console, but you can see what's going on. Usually when something green happens, it means that it's a really good thing. So in this case, the Hive Rdbms script was the first one that's finished. And he says that Postgres, which is the database that we're going to be using, has started. You'll start to see inside here some other stuff going on. The JDBC driver for Postgres is getting put into the Metastore instance. The data node here is checking another data node to see if it's ready to hook up with it, and it finds that it's provisioning right now. Here's Metastore looking for another node, another instance to see if it's ready, and he looks to the Rdbms instance and says, yes, it's running. So we're going to see a whole bunch of that stuff going on. Finally, when he's done, he's going to come back and give us the output of the fact that we were able to run the 06 script, and we've got the cluster and the environment set up. We can also look on the AWS console. Of course, we're just going to see, that things are running, but that's always a nice sign. We can do things like look at the performance of it. And when things like our smoke test run, we're going to find, nice formatted instances telling us that SCP worked, that SCP had to get retried. We get back the same results from the MapReduce test. We can look at what the performance was on that. We can also take a look at the web UI that's provided by Hadoop and see things like how much data is going onto the data nodes and where they are. We can look at the MapReduce job, see what happened with him. All very well and good. This was the output of the Hive test. Looks a lot like the one that we ran in Docker, except it's running on a full data set here. And you could also, just for fun, look at the log. The whole reason to use the web UI tools is that you don't have to do this kind of stuff, or to get bored. That's what you can look at. The performance graph of how everything took to make happen. This is the console as it's taking down the environments. And you can see it takes a lot less time to take down an environment and put one up. And we can check back to the console and see everything's done. So, as they say at the end of a Looney Tunes cartoon, that's all, folks.
Okay, back again. So let's move on to the final portion here, some takeaways. And my question to you is, do you really want to follow the cargo cultists? When Feynman spoke in 1974, he said, in the South Seas, there's a cargo cult of people. During the war, they saw airplanes land with lots of good materials, and they want some of the same to happen now. So they've arranged to make things like runways, to put fires along the sides of the runways, to make a wooden hut for the man to sit in with 2 wooden pieces on his head that are like headphones and bars of bamboo sticking out like antennas. He's the controller. And they wait for the airplanes to land. They're doing everything right. The form is perfect. It looks exactly the way it looked before, but it doesn't work. No airplanes land. So I call these things cargo cult science because they follow all of the precepts and forms of scientific investigation, but they're missing something essential because the planes don't land. Okay? So don't allow yourself to fall into that trap. Don't just blindly copy and paste someone else's solution from a company that maybe is your competitor even. You're going to trade a short-term thrill for the suffering of interminable delays in the future when really small things change. Strive to learn before you estimate and implement. So a couple of pictures from cargo cult societies: airplanes, control towers, goggles. And then from our cargo cult society, everybody wants to use AWS, especially inside the console UI. Here's the one that my people wanted to use. So how do you learn while you're doing? First of all, don't be embarrassed about saying, gee, I don't know. Stop thinking about the thing that you don't know to do and do it in one giant step. Think very small steps. Concentrate on just the next step. Now, it's okay to copy small amounts of code to get started, but you must understand everything you did and why what happened was observed as before you go on to start with more copying. Embrace your curiosity about why this small piece of code does what it does. Form a hypothesis. Make some changes. Make a scientific experiment to discover what it really does, not just how to type it. Another great idea: teach someone else how to understand what you've just learned, because you'll both benefit. And many times the questions asked of you will force you to more fully comprehend what you learned. Rinse, wash, and repeat many times, as often as needed to get the results that you want. One of my favorite maxims that I follow is a day where you don't learn anything is a wasted day. So finally, here we are. So long, and thanks for all the fish. We'll have some time now for some questions, some answers, some debate, and we will depart to the next session. So thank you again.